Assalamualaikum, my name is Nabil Fikri Rosli, metric number CE190212. Today I will present my PSM1. My PSM1 title is Anti-Arcing DC Circuit Breaker for High Payload Application, and my supervisor name is Dr. Muhammad Aifaa bin Muhammad Ariff. I will proceed to introduction. Introduction consists of project background, problem statement, objective, and also scope of the project. First, the project background. University Tun Hussein Malaysia, ITHM, become the first high institution to develop a high payload drone in Malaysia. The development team is divided into several departments, which is structure, power plant, and control. The team members for the drone structure are from the Faculty of Mechanical and Manufacturing Engineering, FKMP, while the team members for the power plant and control departments are from the Faculty of Electrical and Electronic Engineering, FKE. Then focusing on the power plant and control of the drone, the system architecture consists of brushless DC, BLDC motors, electronic speed controller ESC, autopilot system control, propeller. These components are vital to the operation in order to provide sufficient thrust to lift the drone. The operation starts from the battery, which is designed to fulfill the power requirement from the ESC. The battery system is developed to fulfill the requirement for the propulsion system. For the problem statement, typically a heavy lift drone is driven by a high power propulsion system to provide the thrust to lift the aircraft. During the development and the operation of the aircraft will undergo countless energization and de-energization process. There is a safety issue during the energization process, where typically there is an arc occurs when the operator makes the connection between the battery and the ESC. The ESC is typically a capacitive circuit. Thus, there will be a significant inrush current when the operator makes the connection. Eventually, the arc will degrade the quality of the connector and increase the power transmission loss in the system. For the objective of my project is to design and simulate the anti-arcing DC circuit breaker for high payload drone application. The second one, to develop the hardware of the anti-arcing DC circuit breaker based on the simulation results. And the last one, to evaluate performance of the anti-arcing DC circuit breaker during the heavy load lift drone flight test. For the scope of the project is this project is designed for high current direct current power system. This project is designed by using multi-sim software. The circuit is aimed to support up to 300 amp current. The printed circuit breaker PCB may be created based on the circuit. For the methodology, this section is consists of flowchart of project, circuit simulation by multi-sim, and PCB design by Altibot. This is the flowchart of my project. Start from the research, and then proceed on literature review, and design the circuit by multi-sim, and also run the simulation, and then testing the analysis. After that, the decision to make testing parameter will made. If yes, design PCB will be proceed. If not, the circuit design will be improved. And then the PCB will be built by JLC PCB, and then the component will be assembled, analyze data, and the last one is PCB testing. In the PCB testing block, this will be a decision. If yes, the report writing will be proceed. If not, the other component will be selected. And for the method for simulation, I will use NI multisim, and for PCB design, I will use NI ultiport. So for the result section, this section consists of circuit design diagram, result of simulation, and also PCB layout diagram. So this is the circuit design by using NI multisim. Consists of resistor, capacitor, zener diode, and also power MOSFET. And this is the result of the simulation based on the component. So in this result of the simulation, the result was recorded according the components. The result shown in transients analysis, which is represent in graph form. Last in this section is PCB layout design that exceed in methodology. The PCB layout was designed by using NI multisim. So I will show the simulation. So the parameters I use for this simulation, the battery is 108 volt, for R1 is 1 mega ohm, R2 1 kilo ohm, C1 1 mu farad, and this is the zener diode, the power MOSFET, and also the ESC capacitor. So I will place the probe for voltage reading at the MOSFET Q3. So this is the result for the MOSFET at Q3. So based on the result, the voltage and current reading at MOSFET is at Q4. The graph of VPR13 for voltage is reduced at 0.5 seconds. It shows that the reading of voltage slowly decrease, while probe VPR14 slowly increase, which is it is start to build up the voltage for the ESC capacitor. The current build up after 3 seconds of the operation shows at the line red, which is it is PR15. This result same goes like MOSFET for Q4. So for the conclusion, a project aims to eliminate the electrical arc that produced in high current DC power system. In this project, the result shows in the simulation that arcing problem can be vanished. The PCB prototype is still in consideration. Either the PCB be able to accommodate with the continuous current or not. At the end of the project, the anti-arcing circuit breaker could be used in high voltage application. such as Drone M. So that's all from me. Thank you.